This is Chapter 6 Notes, page 1. You should have a periodic table in front of you as you go through these notes. We're going to be looking at first areas of the periodic table. The columns in the periodic table are called families or rows. Families or groups. The rows that go across the periodic table, remember rows go across, are called periods. Now let's look at this rough diagram of a periodic table below. And we're going to name some of the families that are here. The first family that we're going to name here is the alkali metals. So this group right here is the alkali metals. So alkali metals. Lithium is the first alkali metal. Hydrogen is in this particular column, but it's a gas, so it is not a metal. The next column over, the named family, is the alkaline earth metals. That's an R there. Alkaline earth metals. So these are the two named metal groups. The next thing we're doing is we're going to come all the way over to column 17. And this particular group is called the halogens. H-A-L-O-G-E-N-S. Halogens. And then our last named group is this one right here. This is the noble gases. Sometimes these are also called the inert gases. So let me put inert up here. So these are sometimes also called the inert or noble gases. Inert means they do not react. A couple other names here that you should be aware of. Everything above this staircase here, including this area here, are called the nonmetals. Everything to the left of this staircase are metals, with the exception of hydrogen, which is an oddball gas. These here are called main group metals. This whole category under here, these are called the transition metals. Now, right down here is another group that actually ends up being inserted about right here on the periodic table. These are called the inner transition metals, and they're not a group or groups that we deal with very often. So these are the inner transition metals. Now, looking at this diagram that I have shown here, the nonmetals are all located in the upper right. Or you can think of it as above the stairs, so above staircase. That's staircase. The metals are located in the lower left, or below the staircase. And notice that about 3/4 of the elements on the periodic table are actually the metals. So they're about 3/4 of all the elements. Now right along here, this group right here, right along the staircase, you have things that are not quite nonmetals and are not quite metals. So if we're going just kind of along this staircase here, these things are called the metalloids. Now, if you were in class, what we would have done at this point was had you take your white periodic table and you would color code each one of the areas on your periodic table. For instance, you might color the alkaline metals pink, your alkaline earth metals blue, your transition metals another color, your main group something else. Color code your halogens, your noble gases, and your nonmetals. We're going to come down and look at types of compounds. And we're going to divide the compounds into two different types, ionic or molecular. So first of all, let's start off with our definition of compounds. Compounds are chemical combinations of elements. And the elements can combine to form one of two types. They're either going to form ionic or molecular compounds. So let's divide our two types. We've got compounds. They are either going to be molecular and if they're molecular, this means that it's two nonmetals. So it has to be two elements from above that staircase. And these form covalent bonds. And we'll get into covalent bonds in much more detail in about, 3 weeks. So molecular compounds are going to form from two nonmetals. They're going to be up above the staircase. On the flip side, we have ionic compounds. And these form from a metal plus a nonmetal. And they have ionic bonds. So I like to think of this as kind of a Romeo and Juliet situation where you have people coming from opposite sides of something getting together. So you have a metal getting together with a nonmetal. You have compounds forming across the staircase. And once again, these are ionic bonds that form here.